So, hi guys, this is CS204, last week of CS204, and we are going to see a couple of topics. During the first class, we are going to see inheritance, and then during the second class, we will see exceptions. So let's see what is inheritance first. Why do we need that? I'm sharing the screen. Those are the codes that we are going to see, 2 examples, one for each topic. So this is about inheritance. Now we have already downloaded the codes and here they are. So let's see what is inheritance, why do we need it, and what it is actually. During CS201 and CS204 actually, we have told you that we are going to do some object-oriented programming, which means that this is a kind of programming that tries to mimic, to emulate the world that we see outside. So what do we have in the world outside? Well, we have objects of different classes. We have human beings, cars, animals, cats, dogs, etc. And there are different classes. And each of us, of human beings, is an object of that class. Similarly, it goes for any car or pet or dog or cat or whatever. So we have classes. That's why we had classes in CS2, in C++. Furthermore, we saw that those classes had their public and private sections, okay, just as classes do in our everyday life, just as human beings do. They have something which is public, everyone knows, their name, surname, gender, etc. But there's something that they have secret, where they don't share with others, okay? So this was the case also with classes. Now, what else do we have is that human beings and classes in general outside, in our everyday life, inherit each other. Okay, human beings inherit each other. Well, we also have inheritance in C++ and in general in object-oriented programming, and let's see what do we have there. First of all, before starting with inheritance, let me tell you that because of inheritance actually, we have a new way of accessing data. So we have public, private inside of classes. We also have protected. So what are protected? So in inheritance, we have a base class, which is the parent class, and we have a child class. We call the child class the derived class, okay? So when the child derives a parent when the child derives from the parent, okay, or inherits the derived class, the base class. So the parent is the base class, the child is the derived class. So when the derived class inherits the base class, it basically takes everything, all of the characteristics that the base class has, okay? All of the member functions, all of the variables, and so on. There's several ways, actually 3 ways to inherit a class: public way, protected, and private. We are not going to go into details with this stuff. We'll only see public way of inheriting a class, public manner of inheriting a class. So if one derived class publicly inherits another base class, that means that what was public at the parent is going to be public at the child. What was private at the parent is going to be private at the child. But there's a problem with this private. If a certain variable or member function is private, that means that directly no one can access it, even the children. So when the child inherits something from the parent, which is private, yes, the child has it has that property, has that member function maybe or variable, but the problem is it cannot access it, although it has it, okay, because it's private from the parent, okay? And in order to avoid this stuff, we have a new way of hiding data, if we can say, inside of classes, which is protected. Okay, so protected is the following. Protected in terms of other classes is if it's private, so no one can access protected data from outside directly. But if a certain class inherits another class, or if a derived class inherits a base class, then the inherited class can see the protected data. So for the children, the protected data, they are as if they are public, but for other classes, they are as if they act as if they are private. Okay, so this is what happens with protected. Now it's enough for that. And furthermore, when I told you, when a derived class inherits a base class, it takes all of the characteristics from the base class. And furthermore, it might extend something else. But not only extend something else, maybe there is a characteristic from the parent that the child, there's maybe the characteristic from the base class that the derived class wants to change. Maybe some function that is doing something in the base class, we should have the same function maybe, but we should slightly change it or totally change it. In this case, when a certain member function is expected to be changed, from the derived class, then those functions are called virtual functions. Okay, so basically they change, they are overwritten, we say, from the children or from the derived classes according to the needs of and characteristics that the child classes want those functions to have. Today we are going to see a very good example actually, and most of important things that you need to know for inheritance, you have it there, and let's see it. So let's start with the quests.h file, the header. We have a class called question. Here, I told you virtual functions. In this case, we have a virtual destructor, and it is expected that the destructor will be written from the subclasses, from derived classes, from the children of these classes that are going to inherit this class. Now, what do we have else? Let's go first to this part over here, protected. So we have here a string which is called my answer, and that string is protected, is in the protected section. Maybe it's good if we run the code first. Let's see what do we have in our program, and then maybe it will be more intuitive if we see what's happening here. So basically, we have in this example 3 types of questions. So how many questions do you want to have? I would have 3 types of question. One type of question is the following: addition of 2-digit numbers with no carry. So if you see 32 plus 17, there's no carry. 2 plus 7 is 9, 3 plus 1 is 4. So if I write 49, then yes, this is the correct answer. This is the first type, addition of 2-digit numbers with no carry. Then another type of question that we're going to have in this example is 3-digit numbers. Okay, so we just have 3-digit numbers. That may give a wrong result here. Okay, so this is that we get the message that we get if we type a wrong result. And finally, this is the third type of question that we have. It's 2-digit numbers with a carry. Okay, so 39 plus 46, let's say it's 55. Okay, yeah. So what we see over here is the following. We have 3 types of questions. Okay. What do they have? Well, they have, apparently, they keep the correct answer, all of them. This is common for all of them, okay? They have an answer which is the correct one. If we type the correct answer, we'll get this message, excellent, well done. If we don't do that, then we'll type something, the program will print something like this. I'm sorry, the answer is 307. So it knows the correct answer, and all of them have this correct answer, and they calculate it. What else do we have? When you're going to print this, well, you should, apparently this answer is going to be variable. Okay, so we'll have number 1, number 2, operand 1, operand 2, and the answer is also another variable. So we have 3 variables. And this answer, when we are going to print them, of course, we want to take it, to get it. So we'll have a function to get the answer, or retrieve the answer. It's common for all of them. Furthermore, what do they have? All of them have a description, but the problem with the description that all of them have, or let's go with something that they have common. They have common. Well, what do they have common? Is also this part over here. Okay, the way they print the question. Okay, like 32 plus 17, with some empty spaces here in the beginning. Then after plus, we have other empty spaces also here. So this is also similar with each other. They print the questions in similar way. Furthermore, what do we see over here? Well, we see a description of the question, and the description is different. Okay, so here we have another, of course, because the question types are different and the description of the questions are different. So we have addition of 2-digit numbers with no carry, addition of 3-digit numbers, 2-digit numbers with a carry. Okay, and so the description is different. Also, the way we generate the questions are different. Okay, so we generate this question in different manner, or create them in different manner, and this one in different manner. So we see that those classes have some stuff in common, but they also have something, they do kind of a job of the same type, but they do it in different way. Like, for instance, they print a description, all of them print a description, but the description that they print is different for each class, okay? They also create questions, all of them, but the way they create question is different, okay? And here virtual functions come into play, okay? So we'll have a virtual function, and all of those question types that we have actually represent class. So for each question type, we will have one class, okay? One class that deals with no carry, another one which deals with addition of 2 numbers with carry, and another class which deals with addition of 3-digit numbers, okay? But those virtual functions are going to be defined separately for each of the class according to its needs, okay? And the way they're going to create a question is going to be separate, okay? Other stuff are going to be similar. And here we see why we need inheritance. So basically, all similar stuff of those classes, we're going to put them in one class and then inherit from that class, one or more classes. We'll see it in a while. So we have the function question, as I told you, in the function, in the class question. In the class question, we have as protected, and I told you protected. That means that those variables under the protected sections are private for other classes, but for inherited classes, subclasses, the children of these classes, they are as if they are public, okay? So only children can access them, no one else. So we have the answer over here. What else do we have? We have a function which is called isCorrect. And remember, this answer basically takes as a parameter another string reference called answer, which is constant string reference. And we return true if this parameter here is the same with the answer, which is also of type string, okay? What do we have else? Also, we have the function answer, where we return my answer, basically, trivially, okay? I told you, okay? So here you see when I give a reply for the answer, I check whether that is the same. All of the classes do that, okay? Furthermore, if it's not the same, I should print the correct result. And how should I print it? Well, I should get the result, okay? Which is the answer, and this is how I do it. You see this const over here, you should know it from CS204, that this const means that those functions are accessors. They do not change the state of the object, do not change the values of variables, actually. And yeah, answer is correct, doesn't do it. And this, so answer also doesn't change anything. However, we have 2 virtual functions, which are ask and create. Virtual functions means that children are expected to override them, okay? To write them according to their own needs. Furthermore, we have this equal to 0. This equal to 0 makes those functions purely virtual, not only virtual, they're purely virtual, okay? If one class has at least one purely virtual class, then that class is called abstract class. And if a class is an abstract class, you cannot make instances of that class. You cannot define variables of that class. So let me show it so we have the class question, right? Let me go to main. And here, let me define a variable of class question. Let's call it my Q, my question. Now, when I do it, see I have something, this red underline. Let's see what's the message of that. Well, it says object of abstract class, question is not allowed. Why it's not allowed? Because it's abstract. Why it is abstract? Because we have 2 virtual functions. One of them is the function ask, the other one is create. So we have two purely virtual functions. And since we have two purely virtual, even if we had one, that class would have been abstract, and we cannot generate instances or objects or variables of that class, okay? Because it's abstract. Why do we need them, then those abstract classes? Well, it's obvious, because we are going to inherit them, okay? So we already have this, my answer, which is common for all. We have the function answer, and we have the other member function is correct, okay? Which is common for all of the subsequent classes that are going to inherit this one, be it its children or even grandchildren. So let's go to another header file. So remember, this is a function question. Here I've written them. I've been using what is called as unified modeling language, which is kind of a standardization. When if you're going to code in a company or whatever, you're just going to write the classes in this way. So if it's public, you're going to put plus for private minus. You're going to put sharp or the pound sign for protected. Okay, so this is my class question. You give the class name in the first row. In the second row here, you just give all of the variables, whether they're public or protected or private or whatever. You just put the sign in the beginning. So we have my string, and this my string is, my answer is string, okay? Then we had, if you remember, then after, in this third line, basically, in the third row, you just give the member functions of the class. You give the constructor is correct, which was taking a string, an answer as a string, and it returns a Boolean. This is how you write it. Then you have the answer, ask, void, create, etc. So this is my class question. Now let's go to another class, to another header, MathQuest.h. And here we're going to see other classes, namely, so here we include the quest header where the class question was defined. And here we have class MathQuestion. Okay, and this class MathQuestion, as you see, publicly inherits question. This is how you tell, this is the keyword or the way you inherit from one class. Since MathQuestion publicly inherits question, that means that everything that question has, MathQuestion has also. If something in the question class is public, it's going to be public in the MathQuestion. If something is private over here, it's going to be private in MathQuestion. It's public if something is in the question class, in the base class. It's protected, it's going to be also protected in the MathQuestion. Okay, so I'm just copy pasting everything from the base class. And because this is because I inherited public, and most of the time you inherit classes publicly. You can do it in private fashion, protected fashion, but public is the most used one. Now, besides that, so this is another diagram that I'm drawing. Class MathQuestion is a class question. Basically, this is how I draw it. This is how you denote inheritance, okay? It's inheriting class question. It has everything the class question has, plus it has some extra stuff. So what do we have here? In the protected section, besides the my answer, which was inherited from the question class, we have two integers, my number 1, my number 2, which are basically the operands, okay? These guys. My number 1, my number 2. Furthermore, what do we have here? Well, we have the constructor, virtual class, virtual member function, which is ask, description, and create. Always, when you see this virtual, that means that if another class is going to inherit this one, it is expected that the other class is going to overwrite it, okay? Rewrite it, basically, for its own needs. Now, let's see how the functions ask, create, and description are written. Okay, so let's go to MathQuest now. Not 400. So, in MathQuest, the constructor. Okay, so let's go one by one. The constructor first. Well, in the constructor, we don't do anything else but set my number 1, my number 2 to be 0 in the default constructor. Creates the question. And remember, MathQuest is something which has no carry. That's why in this while loop, do while loop actually, we make sure that there is no carry. How do we make sure? Well, the modulo number 1 modulo 10 plus number 2 modulo 10, their sum shouldn't be greater than 10. If it is the case, then there is carry, and I don't want to have carry, so I'm repeating this, and I'm assigning random numbers between 10 and 49 to my number 1 and my number 2. Okay? Up until there is no, if there is carry, I repeat the loop, up until there is no carry. Okay? This is how I create it. Ask is basically for printing the question. Okay? So I set the width, which is 7. I print now empty space, 7 empty spaces. I print number 1. In the second line, I print plus, and now width -1 because I'm using 1 empty space for plus. Then I print number 2. Then I print those lines. And finally, I print the answer, which is width minus my answer dot length, okay, which is string, okay. So basically, I'm printing for all, I'm printing this stuff, okay. Now, we have also from the math question the description function. And the description returns a string. And what we return there is addition of 2-digit numbers with no carry. So this is our MathQuest function, okay? We described everything related to it. Now let's go back to the MathQuest header. And we have, so this is the class that is basically dealing with addition of 2-digit numbers with no carry. But we had 2 other mores. The other one was addition of 2-digit numbers with a carry. So that's why for that purpose we have this class, CarryMathQuestion, which now publicly inherits the MathQuestion, okay? That means CarryMathQuestion, its parent is MathQuestion, its grandparent is question, okay? So explicitly, basically, or implicitly, if you want, through MathQuestion, this CarryMathQuestion class inherits everything that the question class has and also what MathQuestion class has, okay? That's why we don't have to add extra stuff because it already has what it needs. We have the constructor, but now, as I told you, the description is not the same as it was in the parent class, okay? In the derived class for the CarryMathQuestion. And also the way we create the question is not the same. Okay, so in this diagram, I've written that class CarryMathQuestion is a math question. And MathQuestion, remember now, had 3 variables, my number 1, my number 2, which were declared inside MathQuestion, and it had the answer, which was declared inside of the question. Automatically, CarryMathQuestion has all of them here and all other functions. But virtual functions are expected to be overwritten. So yeah, MathQuestion, we already described we explained the description function, the create function, the ask function, okay? The ask function is actually the same. Okay, we just print line, you know, first number plus second number and the answer, okay? But the description and the way we create the questions are different. That's why we have the description over here and the way that we create here, because we are going to override them. And if you remember, description and create were in the math question were virtual, okay? Basically, we say that we expect the children, the derived classes, to overwrite it, to write it again. Now, let's see what do we have in CarryMathQuestion. We have the the constructor, default constructor, description and create, which are also virtual. So let's go to the corresponding CPP file. The constructor is doing nothing else but calling the constructor of the parent class, of the base class. And the constructor of the parent class of MathQuestion basically just set my number 1 and my number 2 to be zeros. As simple as that. Now, when we create questions for CarryMathQuestion, let's see the description first. Well, we have addition of 2-digit numbers with a carry. So this is a description inside the CarryMathQuestion. As for the create function, okay, in the create function, we now shouldn't have a carry. That's why we, in the do while loop now, we make sure that there is a carry. Basically, if my number 1 modulo 10 plus my number 2 modulo 10, if their sum is smaller than 10, that means that there is no carry. We don't want that. We want to have a carry. That's why we repeat this loop up until there is a carry. Okay, this is how we create it. And furthermore, let's go to the MathQuest. We have in similar fashion HardMathQuestion, okay, which publicly inherits MathQuestion, and I've written it over here. So HardMathQuestion inherits both CarryMathQuestion and HardMathQuestion, both inherit MathQuestion, and MathQuestion inherits question. And question was abstract class. Okay, in similar fashion, we have here the constructor, description, and create. Okay, so let's see in the corresponding CPP file, what do we have? The constructor of HardMathQuestion is basically calling the constructor of the math question. So to set my number one, my number two to integers. Then here I'm creating the question, and let's see the description first. Well, addition of 3-digit numbers. Okay, that's why my number one and my number two are random numbers between 100 and 200. And the answer is nothing else but my number one plus my number two, and we just convert it to string. Actually, my answer is converted to string in all of the other functions as you see it when we create the question, okay? And it's always my number one plus my number two converted to string. Well, this is it. This is all about the classes. This is how it looks like when we see it from outside. Okay, the class diagrams. Okay, so we have double inheritance over here. Now let's go to main and see what those guys can do for us. Okay, so we saw that we cannot make instances from abstract classes. Furthermore, I'm declaring here a math question and another CarryMathQuestion. Remember, math question was this one in the middle, and CarryMath and HardMath inherited from MathQuestion. Okay, so maybe it's good if I declare another variable, HardMathQuestion. Let me call it HMQ. Now, surprisingly, this is not doable with other data types. I can say something like this: M is equal to CM1. Although M is math question, CM1 is CarryMathQuestion, I still can do it. Why? I can assign values of children of derived classes to parent classes. Why I can do it? Because children have what the parents have plus something extra. That's why I can assign it. Okay, because they're actually parents, plus they have some other stuff. Similar fashion, I can say something like this: M is equal to HMQ. Yes, I can do it. But if I try to do something like this, to assign a value to children from the parent, this is not doable. Why? Because children have more stuff than the parents. So if you want to assign from parent to children, well, the parent has less stuff. That's why we cannot do it, okay? And this is the mistake that we get. You cannot assign it, basically. But you can assign from children, from derived classes, to parent classes. Now, let's go and see that's something else. So this property over here, the property that we can assign values from objects, from children to parent objects, gives us a property which is called polymorphism, which means multiple forms. Let's see what it is. Here we are declaring an array of math questions of 3 elements. Okay, the array name is questions. Okay, now although the types of math questions are the type of questions of this array are math questions. Okay, we are doing something like this. Questions 0, the first element with index 0, is actually a new math question. Question 1 is new CarryMathQuestion, and question 2 is HardMathQuestion. Okay, in CS201, someone asked me, can we have an array with different data types? And I said yes and no. Okay, up until now, the answer was no, but now the answer is yes. You can do it, given that you declare an array as a data type of parent of base classes, and then in that array you can have also elements of the children. It's doable now, okay? And this is how we see it. Now what do we do over here? So in this question over here, basically, in this array here, the first element is math question, the second one is CarryMathQuestion, and the third one, the one with index 2, is HardMathQuestion. 3 elements of the array, all of them are different data types, and we dynamically allocate them one by one. Now, we ask the user how many questions he wants to give, and here I'm giving the answer, okay, I want to give 3 questions, fine. Then from 0 up until Q count, question count, I randomly choose one question from 0 to 2, okay? And it will be question 0, 1, 2. And then I'm calling the give question function. Let's see what give question is doing. Well, give question, this is important. Give question takes a reference of math question, and it takes the quest, okay? But it takes as a reference, and the parameter name is quest. Here inside of the give question, we just print the description of this quest. We create the question, okay? We ask the question, so basically we print it. The user gives his answer, and now we check whether the quest is correct. You see, create, ask is correct, description. Some of them are taken from the question class. Some of them are taken from the math question class. Some of them are taken from hard. So it depends, but all of the classes, which are not abstract classes, have those properties, okay? And so if the answer is correct, I print it, oh, excellent, well done. Otherwise, I print, I'm sorry, the answer is, and I call the answer quest.answer member function to print the correct answer. But interestingly, sometimes, let's say in the first time, in the first randomly, let's say, as you see here, I'm creating, as you see, addition of 2 digits numbers with no carry, which was MathQuest. So fine. This guy over here expects an object of type quest, and those are pointers basically to objects. So that's why I put here a star. So now the pointer becomes the object itself, and I'm sending it, okay? But this time I'm sending it as a math quest, and there's no problem. It's a math quest. But in the next time, you see here, the second time, randomly, I've chosen another type of question, which is addition of 3-digit numbers, okay? And addition of 3-digit numbers, basically, it's now dealing with this one, hard math question, not math question, okay? So when I send here, index 2, I'm sending the object of hard math question. But here I'm expecting a math question. And this is doable for the reasons that I told you here. We can assign objects. We can assign objects of derived classes to base classes. So children can be assigned to parents. But here, I'm actually, what I'm doing, I'm not, so here in the function over here, I'm sending index 2, okay? I'm sending index 2 question with index 2, which is hard math question. And I'm sending it as a reference, not as a copy, okay? And since I'm sending it as a reference, I'm basically using that box of hard math question. And basically, although I'm taking here a parameter of type math question, due to, this is called polymorphism, I'm actually accessing hard math question because I'm using reference, okay? I'm not creating a copy. When I send it from here, okay, questions of 2, I'm sending the hard math question, okay, if the index here is 2. And since I'm sending it as a reference, I'm not creating a copy. I'm using actually that guy. And since I'm using actually that guy, over here inside of the give question function, whenever I call the description member function or create or ask or the answer, actually, I'm calling them from the hard math question, okay? Because I'm dealing with the object which was dynamically allocated as a hard math question, okay? And although the type that I'm expecting here is math question, yet I'm dealing here with a hard math question. And as you see, and the same happens if I send question 1, CarryMathQuestion over here, okay? I'm sending it as a reference, okay? I can assign something from child to parent, but since I'm sending it as a reference, although I'm expecting a math question, actually if I'm sending CarryMathQuestion, if I'm sending this class over here, CarryMathQuestion, actually I'm dealing with that class. So inside of the function, when I call the function description, the member function description, or create, or ask, actually I'm calling them from the class CarryMathQuestion. So as you can see over here, and over here also, although I'm declaring an array of math questions, actually, those math questions can be a math question, CarryMathQuestion, or hard math question. Okay, one data type can be different data types, and this is called polymorphism. polymorphism means multiple forms, okay? And this is helpful in those kind of questions, like you want to write only one function and which one you want it to work for all of the classes, the base and derived one. That's why I give here the base class. And this is the important part also. If you want to have polymorphism, when you send something as a parameter, you should always use the reference. Because if you don't use the reference, you're going to create a copy of it. And when you're going to send the copy, it's going to be of MathQuestion. And this is called slicing, okay? But if you don't send the copy, you're going to work in the actual object. And the actual object, for instance, for example, it might be HardMathQuestion. Although the function is expecting a math question, since we are not creating a copy, we are using a reference. Actually, we are dealing with a HardMathQuestion. So we are not dealing with the base class. We are dealing with the derived class, although the function expects something from the derived, from the base class. Okay, finally, when you see here everything that is dynamically allocated, we should dynamically delete it. And how do we delete it? Unfortunately, we cannot do it like this, as we have done it before. Delete questions. Okay. No, you should do it, delete them one by one. Okay, and when you assign them, you assign them one by one. Okay, the elements of the array, and you're going to delete them one by one. Okay, so this is what happens with polymorphism and with inheritance. Well, basically, this is all what you need for the example. Okay. Then let's have a break of 10 minutes and we'll be back in 11:30 with the next class. Okay, you can ask questions in the next class. So see you in 10 minutes then.